We're going to be working on different kinds of inequalities. So first we're going to start with linear inequalities. So we mentioned absolute in here, but I've actually pulled that out. We're not going to do the absolute inequalities. We're just going to do linear inequalities. So an inequality, in case you don't remember, kind of looks like an equation, except the difference is that we have an inequality sign. So you can have 2x plus 3 is greater than 1, or you could have 2x plus 3 is less than 1. You can have 5x is less than or equal to 7x plus 12, or you can have 7x minus 3 is going to be greater than or equal to 0. So anything that has one of these symbols in it, so a greater than, a less than, a less than, less than or equal to, a greater than or equal to, those are going to be inequalities. So what we're able to do is solve these kinds of problems. So solving an inequality is a process of finding a set of numbers that makes an inequality makes the inequality a true statement. These numbers are called the solution of the inequality, and we say that they satisfy the inequality. So the set of all solutions is called the solution set of the inequality. So the difference here is that when we had linear equations, if I had that 2x plus 3 equals 1 instead, we could solve that and we'd end up with just one solution. Here, that's not going to happen. We're not going to end up with just one solution. We're going to end up with a range of solutions. Oops, there's a typo over here. So if it was an inequality, we would end up with 2x plus 3 equals 1. The solution is, well, then x would have to be equal to negative 1. Here, 2x plus 3 has to be greater than 1. Well, that would mean x has to be anything that is greater than negative 1. So we need to do a little review over interval notation here. So an open interval, AB, represent a set of real numbers between, but not including A and B. So we have AB, once again, as a reminder, is that AB represents all your x values such that x is greater than A, less than B. We call that an open interval. A closed interval is then we include the point on both sides. We would have bracket AB, and this represents all your x values such that x is less than or equal to B or greater than or equal to A. Also remember, we do have mixed intervals. So if I had parentheses A, B bracket, that is supposed to represent that we're looking for x values that are greater than A, but less than or equal to B. If I have bracket A and then B parentheses, well, that means I'm looking for x values that are equal to or greater than A, but less than B. Then we have our infinite intervals. So if I'm trying to look for numbers like this, so I'm looking for values that start at A and go to infinity but don't include A, that means we're just looking for x values greater than A. If I'm looking for negative B, or sorry, negative infinity to B, that means I'm just looking for x values that are just less than B. If we have the bracket in there, well, then that means that we could go from bracket A to infinity. So remember, your infinities always are going to say parentheses because we can't touch them. So we always have parentheses at your, we always have a parenthesis on the infinity sign, but this one's supposed to represent, so we're going A or greater. So x is greater than or equal to A. Negative B, a negative infinity B parenthesis is supposed to represent all your x values that are B or greater. Or sorry, B or less than, I said that backwards. It's going to be less than or equal to B. Like remember, parentheses indicate endpoints that are not included in the interval. The square brackets indicate endpoints that are included in the interval. Parentheses are always used when we have infinity and negative infinity. So what we're going to just do is just graph some of these quickly. So when we're trying to graph these, remember that if we have less than, greater than, or parentheses, that means we have an open circle. If we have less than or equal to, or we have brackets, that's supposed to be a closed circle. So if I want to graph -2 to 5, well, then I have a closed circle at -2 because of that bracket or because of that less than or equal to sign. And then 5 is going to be an open circle because of that parenthesis or that less than sign. So this represents everything that's between from -2 up to but not including 5. If we have parentheses 1, 3.5 parentheses, well, that means we include 1 and we include 3.5. So they're both closed points. And we just draw the line between them. If we go to negative infinity, so remember, technically you have an arrow going this way. This is just one way we write number lines. So if we go negative infinity to negative one not included, it's open at -1, and we never can reach infinity, but we know we're going to a negative infinity, so we just head off in this direction. Like I said, just kind of quick review here, because we're going to use a lot of interval notation when we're talking about inequalities. Take a moment yourself and just graph these sets. So we have parentheses -4 to -1 bracket. We have an open interval from 0 to 1. And then we have an infinite interval. So bracket -2 running to infinity. Okay, so hopefully you took a moment on that. So we got a parentheses here at -4. So that is an open point. We got a bracket at -2. So that's a closed point. So my interval of x is greater than -4, but less than or equal to -1 looks like this. This is my interval where x is greater than 0 and less than 3, and it doesn't include 0 or 3, so those are both open. And this is my interval of x values that are all greater than or equal to -2. So -2 is included, and then we run towards infinity. So when we solve a linear inequality, it can be written in one of the following forms. We saw some of these earlier. So ax plus b is less than 0, ax plus b is greater than 0, ax plus b is less than or equal to 0, or ax plus b is greater than or equal to 0. So these are examples of your linear inequalities. So you might not always see them exactly like this, because you could have 3x plus 7 is greater than 0, but sometimes you might see it as 3x is greater than 0. Or sorry, 3x is greater than -7. That is still technically a linear inequality. This is not the standard form. So in general, when we multiply or divide by both sides of the inequality by a negative number, the direction of the inequality symbol is reversed. Otherwise, all operations will act just like if you were trying to solve inequality. We only have to worry about multiplying or dividing by negative numbers. So if we had 2 minus 3x is less than or equal to 5, we want to solve this. So this is a linear inequality as long as we have an x, it's a linear inequality. So what we want to do is we want to treat it just like we would with any other kind of inequality. We want to isolate or like an equality, we would like to isolate the x so we can figure out what it should be. So we can subtract 2 from both sides, and we get -3x is equal to 3. Now, this is the one place, like I said, you have to be careful. Now, it's a -3. So if I want to get rid of that -3 to isolate that x, I'd have to divide by -3 on both sides. And when you divide or multiply by a negative, that is when the direction of your inequality sign switches. So it's no longer a less than or equal to sign, it's a greater than equal to sign. So x is greater than or equal to -1. And that would be my solution set. So my solution set can be either written as I need to have, oops, include that one. So let's graph it first. We're looking at including this -1, and then we want values that are greater than x, or greater than -1 for my x's. So solution set would be -1 to infinity, or x, that x is greater than or equal to -1. So we want to solve this inequality. We have 3x plus 2 is greater than 3x plus, or sorry, 3 times x plus 1 is greater than 3x plus 2. So, like I said, treat it like you were trying to just solve for x. So we could distribute this across. So we ended up with a 3x plus 3 is greater than 3x plus 2. And then we would end up with, if we subtract 3 from both sides to get one of those x's by itself, we end up with 3x times 3x is minus 1. And at this point, you might be going, well, I'm a little stuck. So let's say we get rid of that negative 3x on both sides. Well, I get stuck with 0 is greater than -1. So just like when we had inequalities, sometimes we'd end up with something that's always true. This is a case where this is always true. 0 is always greater than -1. What that means is that my solution set is going to be from negative infinity to infinity, or all real numbers. So sometimes we have inequalities that hold true all the time, no matter what. So if I graph that, it's just a number line like this running to infinity. Now, if we have a compound inequality, what we do is we treat everything the same way again, except that when I try to isolate that x, so I have this 3 here, I would subtract that 3 from all 3 pieces. So everything gets a -3. So this is -2 is less than or equal to 2x, which is less than 8. So like, where was I? Now, if I divide by 2, this time I'm dividing by a positive value, so the sign doesn't change. So it stays the same. So we get -1 is less than or equal to x, which is less than 4. So we include here, but not the 4. So my solution set is from -1 to 4 parentheses, or x such that, oops, such that x has to be between, or has to be greater than or equal to -1, but less than 4. Okay, so these are just a couple for you to practice with. Remember, we only switch the sign if we're dividing or multiplying by a negative. If we're not, then we just treat this like we're just trying to solve for x and just do it exactly the same way. Okay, so hopefully you took some time to try this. So you have 0 is less than 2 times 3, oops, 3 minus x. So if I wanted to get that x, we're going to distribute that 2 first. So we're going to end up with a 6 minus 2x. So you could do this a couple ways. I'm going to do this 2 different ways. So first is I'm just going to subtract that 6 from both sides. So we get -6 is less than -2x. which in that case, now if I'm going to get x by itself, I have to subtract or divide by -2, which means the sign switches directions. So instead of a less than, we get a greater than. So now we have -6 divided by -2, that is going to be 3, is greater than x. So x has to be values that are less than 3. Alternatively, what I could have done, this might help some of you out. I do not like having to divide by negatives. It's just a pet peeve of mine. So I could have just added 2x to both sides at this point, and I would have had 2x is less than 6, and then I would have divided by 2, and I would end up with x is less than 3. So as another way you could do it as well. But what we have here is my solution. Is going to be x such that x is less than 3, or we would say we're going to negative infinity to 3. So B, we got -2x minus 1 is greater than or equal to 3x plus 1. So we get -2x plus 2 is greater than or equal to 3x plus 1. So we want to do like what we always when we're trying to solve an inequality or solve an equality is get our x's together and our constants together. So let's just add the 2x to the other side to make life a little easier for us. So we get 2 is equal to 5x plus 1. Well, I can subtract the 1 from both sides, and I'm going to get 1 is greater than or equal to 5x. And if you don't like that, you can always switch the order and go 5x is then less than or equal to 1. Which means that x is going to be less than or equal to 1/5. So you can have fractions for answers. So my solution set here is x such that x is less than or equal to 1/5. Or we're going from negative infinity up to 1/5, but this time we have a bracket. All right, hopefully I can fit this last one in here. So we got 9 is less than or equal to 7x minus 2, which is less than or equal to 19. So we want to get at this x here, so we can add that 2 to all three sides. And we'll end up with -7 is less than 7x, which is less than or equal to 21. Now we can divide everything by 7, and since that's a positive that we're dividing by, everything, the signs do not change direction. So we end up with -1 is less than x, which is less than or equal to 3. So my solution set here is I have x values such that x is greater than -1, but less than or equal to 3. Or we would have brackets, -1, comma, 3, bracket. Okay. Like I said, this is a little bit of practice on just solving linear inequalities, because the rest of the section is you're going to be solving polynomial and rational inequalities.